UV visible spectrophotometry. This is electromagnetic spectrum in which we have radio waves, infrared, visible, ultraviolet, X-rays, gamma rays or cosmic rays. As far as radio waves are concerned, molecular rotations are associated with it. Infrared molecular vibrations are associated. Visible and ultraviolet outer electron transitions are associated, and in X-ray inner electron transitions are associated. In gamma rays and cosmic ray, nuclear transitions are associated. Over here the complete conversion is given: units, wavelength, frequency, wave number, energy. Introduction. Absorption spectrophotometry in the ultraviolet and visible region is considered to be one of the oldest physical method for quantitative analysis and structural elucidation. Wavelength: ultraviolet 200 to 400 nanometer, visible 400 to 800 nanometer. Instrument: first of all we have photometer, an instrument for measuring the intensity of light or relative intensity of pair of light, also called illuminometer. It utilizes filter to isolate a narrow wavelength region. Second is spectrophotometer, an instrument measures the ratio and a function of two or of radiant power of two electromagnetic beams over a large wavelength region. It utilizes dispersing element, that is prism or gratings, instead of filters to scan large wavelength region. Third is calorimeter, an instrument which is used for measuring absorption of the visible region is generally called colorimeter. Parts of UV visible spectrophotometer: source of radiant energy, collimating system, monochromator system, sample holder or container to hold sample, detector system of collecting transmitted radiation, suitable amplifier or readout device. So this is complete diagram of UV visible spectrophotometry. First of all, light source, wavelength selector, sample, detector, and via electric current is fed to the particular system or computer or signal processing output. Source of radiant energy. Requirement for an ideal source: it should be stable and should not allow fluctuations. It should emit light of continuous spectrum of high and uniform intensity over the entire wavelength region in which it is used. It should be provide incident light of sufficient energy or intensity for the transmitted energy to be detected at the end of optic path. It should not show fatigue on continuous use. To produce visible radiation, tungsten halogen lamp is used. Its construction is similar to a household lamp that we are using in daily life. The bulb contains a filament of tungsten fixed in evacuated condition and then filled with inert gas. The filament can be heated up to 3000 Kelvin. Beyond this, tungsten starts sublimating. It is used when polychromatic light is required. To prevent this, along with inert gas, some amount of halogen is introduced, usually iodine. Sublimated form of tungsten react with iodine to form tungsten-iodine complex, which migrates back to hot filament where it decomposes and tungsten get deposited. Demerits: it emits the major portion of radiant energy in near infrared region of spectrum. This is tungsten halogen lamp. Source of UV radiation: hydrogen discharge lamp is used as a source of UV radiation. In hydrogen discharge lamp, a pair of electrodes is enclosed in glass tube provided with silica or quartz window for UV radiation to pass through, filled with hydrogen gas. When current is passed through this electrode maintained at high voltage, discharge of electrodes occur which excite hydrogen molecules, which in turn cause emission of UV radiation in near UV region. They are stable and robust. Xenon discharge lamp. It possesses two tungsten electrodes separated by some distance. These are enclosed in glass tube for visible with quartz or fused silica, and xenon gas is filled up under pressure. An intense arc is formed between electrodes by applying high voltage. This is a good source of continuous plus additional intense radiation. Its intensity is higher than the hydrogen discharge lamp. Demerits. The lamp, since operate at high voltage, becomes very hot during operation and hence needs thermal insulations. Mercury arc lamp. In mercury arc lamp, mercury vapor is stored under high pressure and excitation of mercury atom is done by electric discharge. Demerits. Not suitable for continuous spectral study because it does not give continuous radiation. Collimating system. The radiation emitted by source is collimated, made parallel by lenses, mirrors and slits. These are the lenses. Lenses. The material used for lenses must be transparent to the radiation being used. Ordinary silica glass transmit between 350 to 3000 nanometer and it is used for visible and near infrared region. The quartz and fused silica is used as material for lenses to work below 300 nanometer. Mirrors. They are used to reflect, focus or collimate light beam in spectrophotometer. To minimize the light loss, mirrors are illuminized on their front surface. Slits. The slits is an important device in resolving polychromatic radiation into monochromatic radiation. To achieve this, entrance slit and exit slits are used. The width of slit plays an important role in resolution of polychromatic radiation. Monochromator. It is device used to isolate the radiation of the desired wavelength from wavelength of continuous spectra. Following type of monochromatic device are used. First is filters, second is prism and third is gratings. Filters. Selection of filters is usually done on a compromise between peak transmittance and band pass width. The former should be as high as possible and latter as narrow as possible. First, absorption filter works by selective absorption of unwanted radiation and transmit the radiation which is required. Examples: glass and gelatin filters. Selection of absorption filter is done according to following procedure. This is V.Cr clockwise and anti-clockwise manner, omitting indigo. If solution to be analyzed is blue in color, a filter having complementary color orange. Over here you can see, okay, is used in the analysis. Similarly, we can select the required filter in colorimeter based upon the color of the solution. An absorption glass filter is made of solid sheet of glass that has been colored by pigments which is dissolved or dispersed in the glass. The color in the glass filter are produced by incorporating metal oxide like V.Cr, Mn, Fe, Ni, Co, Cu, etc. The gelatin filter is an example of absorption filter prepared by adding organic pigment. Here, instead of solid glass sheets, thin gelatin sheets are used. The gelatin filter are not used nowadays. It tends to deteriorate with the time and get affected by the heat and moisture. The color of the dry gets bleached. Merits. The simple in construction, cheaper selection of filter is easy. Demerits. Less accurate, band pass or bandwidth is more, that is plus or minus 20 to 30 nanometer. That is, if we have measure 400 nanometer, we get radiation of 370 to 430 nanometer. Hence, less accurate results are obtained as far as filters are concerned. Interference filters. Works on the interference phenomena causes rejection of unwanted wavelength by selective reflection. It is constructed by using two parallel glass plates, which are silvered internally and separated by thin film of dielectric material of different, that is CaF2, SiO, MgF2, refractive index. These filters have a band pass of 10 to 15 nanometer with peak transmission of 40 to 60%. This is interference device. Merits: provide a great transmittance and narrower band pass, that is 10 to 15 nanometer as compared to absorption filter. This is inexpensive. Additional filters can be used to cut off undesired wavelength. Prism. Prism is made up from glass, quartz or fused silica. Quartz or fused silica is the choice of material of UV spectrum. When white light is passed through glass prism, dispersion of polychromatic light in rainbow occurs. Now, by rotation of prism, different wavelength of spectrum can be made to pass through in exit slit on the sample. The effective wavelength depends on dispersive power of prism material and the optical angle of the prism. There are two types of mounting in the instrument. Is one of cornu type, that is refractive, which has an angle of 60 degree and it's adjusted such that on rotation that emerging light is allowed to fall on exit slit. The other type of called litho type, that is reflective, which has optical angle 30 degree and it is one of the surface is illuminized when reflected light backs to passes through prism and to emerge on the same side of the light source, that is light doesn't pass through the prism on the outer side. Gratings are the most effective one in the converting a polychromatic light to monochromatic light. As a resolution of plus or minus 0.1 nanometer could be achieved by using grating. They are commonly used in spectrophotometer. So grating are of two types. First is diffraction grating and second is transmission grating. Diffraction grating, so more refined dispersion of light is obtained by means of diffraction grating. These consist of large number of parallel lines, grooves about 15000 to 30000 per inch is ruled on highly polished surface of aluminum. These gratings are replica made from master grating by coating the original master grating with epoxy resin and are removed after setting. To make surface reflective, a deposit of aluminum is made on the surface. In order to minimize the greater amount of scattered radiation, and appears the unwanted radiation of other spectral orders, the grating are blessed to concentrate the radiation into single order. Second is transmission grating. It is similar to diffraction grating, but reflection take place instead of reflection. Refraction take place instead of reflection. Refraction produce reinforcement. This occur when radiation transmission through grating reinforces with partially reflected radiation. Advantages: grating gives higher and linear dispersion compared to prism monochromator. Can be used over wide wavelength ranges. Grating can be constructed with materials like aluminum, which is resistant to atmospheric moisture, provide light of narrow wavelength, no loss of energy due to absorption. Let us see comparison of prism and grating. Prism is made up of glass in visible region, and quartz fused silica UV region. You can get alkali halide, you can get IR region. Okay, then grating, so groove on highly polished surface like alumina. Working principle of prism, angle of incidence. Working principle of grating, law of diffraction, that is n lambda is equal to d sin theta. So merits of prism: prism are non-linear dispersion, hence no overlap of spectral order. It can't be used over considered wavelength ranges. Prism are not sturdy and long lasting. It could be break. So merits of grating: grating gives linear dispersion, hence overlap of spectral order. It can be used over considerable wavelength ranges. Gratings are sturdy and long lasting. Sample holder or cuvettes. The cell or cuvettes are used for handling liquid samples. The cell may either be rectangular or cylindrical in nature. For study in UV region, the cells are prepared from quartz or fused silica, whereas color corrected fused glass is used for visible region. The surfaces of absorption cell must be kept very clean. No fingerprints or floats should be present on cell. The cleaning is carried out washing with distilled water or with dilute alcohol acid. This is sample holder or cuvette. Detectors. Detectors which convert light energy into electrical signals that are displayed on readout devices. The transmitted radiation falls on the detector, which determines the intensity of radiation absorbed by sample. The following type of detector are employed or used in instrumentation of absorption spectrophotometry. First is barrier layer cell, that is photovoltaic cell. Second is phototube, that is photoemissive tube. And third is photomultiplier tube. Requirement of an ideal detector: it should give qualitative and quantitative response. It should have high sensitivity and low noise level. It should have a short response time. It should provide signal or response quantitative to wide spectrum of radiation received. First is barrier layer cell or photovoltaic cell. The detection has a thin film metallic layer coated with silver or glass and act as an electrode. It also has metal base plate which acts as another electrode. These two layers are separated by semiconductor layer of selenium. In this figure it is seen. When light radiation fall on selenium layer, electrons become mobile and are taken up by transparent metal layer. This creates a potential difference between two electrodes and causes the flow of current. When it is connected to galvanometer, a flow of current observed which is proportional to intensity and wavelength of light falling on it. Second is phototype or photoemissive tube. This diagram of phototype or photoemissive tube type of detector. It consists of evacuated glass tube with photocathode and a collector anode. The surface of photocathode is coated with layer of element like cesium and silver oxide or mix of them. When radiation energy fall on photosensitive cathode, electrons are emitted which are attracted to anode causing current to flow. More sensitive compared to barrier layer cell and therefore widely used. Photomultiplier tube. The principle employed in this detector is that multiplication of photoelectron by secondary emission of electron. In vacuum tube, a primary photocathode is fixed which receives radiation from the sample. Some 8 to 10 diodes are fixed, each with increasing potential of 75 to 100 volt higher than preceding one. Near the last diode is fixed an anode or electrode collector electrode. Photomultiplier is extremely sensitive to light and best suited where weaker or low radiation is received. This is diagram of photomultiplier tube in which we have a diodes. These are anode. This is anode. This is focusing electrode. This is incoming photon. This is photocathode. These are voltage dropping resistors. This is power supply. This is output meter. Instrument design. Depending upon the monochromator, that is filter or dispersing device used to isolate and transmit a narrow beam of radiant energy from incident light, determine whether the instrument is classified as photometer or spectrophotometer. Spectrophotometer used here to detect the percentage transmission of light radiation. When light of certain intensity and frequency range is passed through the sample, both can be single beam or double beam optical system. Single beam spectrophotometer. Light from the source is carried through lens and or through aperture to pass through shielded filter. The type of filter to be used is governed by color of solution. The sample solution to be analyzed is placed in cuvettes. Single beam instrument. First of all, we have source, then lenses. This is entrance slit, objective lens, grating, light control, then exit slit, cuvette, filter, and phototube. After passing through the solution, the light strikes the surface of detector, that is barrier layer cell of phototube, and produces electric signal or electric current. The output of current is measured by deflection of needle of light spot galvanometer or micrometer. This meter is calibrated in terms of transmittance as well as optical density. The reading of solution of both standard and unknown are recorded in optical density units after adjusting instrument to reagent blank. This is single beam instrument. Double beam UV visible spectrophotometer. The double beam instrument is the one in which two beams are formed in phase by U-shaped mirror called a beam split or beam chopper. Chopper is device consisting of circular disc. 1/3 of the disc is opaque and 1/3 is transparent. Remaining 1/3 is mirror. It splits the monochromatic beam of light into two beams of equal intensity. This is diagram of double beam of spectrophotometer. First of all, we have a UV source and light source visible. Then it is fitted to diffraction grating, and after mirror 2, mirror 4, and mirror 3. This is half mirror. These two are cuvettes. One is reference cuvette, one is sample cuvette. This is lens 1, this is lens 2. via lens 2 the intensity is I, via lens 1 intensity is I0. So intensity comparison is taking place over here. This is double beam UV visible spectrophotometer in actual. The functioning of this instrument is relatively straightforward. A beam of light from visible and UV light source is separated into component wavelength by prism or diffraction grating. Each monochromatic beam in turn is split into two equal intensity beams by half mirror divides. One beam, the sample beam, passes through a small transparent container, that is cuvette, containing a solution of compared bearing studied in transparent solution. The other beam, the reference, and passes through an identical cuvette containing only the solvent. The intensity of this light beam are then measured by electronic detector and compared. The intensity of reference beam, which should have suffered little or no light absorption, is defined as I0. The intensity of sample beam is defined as I. Over a short period of time, the spectrophotometer automatically scans all the component wavelengths. The absorption is different at different wavelength and is characteristic of sample. The characteristic quality is called absorbance and may be calculated from Beer-Lambert principle. The Beer-Lambert law states that in the sample, each successive portion along the path of incident radiation containing an equal number of absorbing molecule equal fraction of radiation that traverses it. The ultraviolet region scan is normally from 200 to 400 nanometer and the visible portion of 400 to 800 nanometer. If the sample compared does not absorb light of given wavelength, we have I equals to I0. However, if the sample compared absorb light, then I is less than I0. And these difference may be plotted on the graph versus wavelength. The absorption may be presented as transmittance T equals to I equals to I0. If no absorption has occurred, that is T equals to 1.0 and A equals to 0. That is absorption equals to 0. So most spectrophotometer or spectrometer display absorbance on vertical axis and commonly observed range is from 0, that is 100% transmission, to 2, that is 1% transmitter. The wavelength of maximum absorption is characteristic value that is designated by lambda maximum. The different compounds may have very different absorption maxima and absorbance. The intensely absorbing compounds may be examined in dilute solution so that the significant light energy is received by detector, and these require the use of complete transparent, that is non-absorbing solvent. The most commonly used solvent are water, ethanol, hexane and cyclohexane bonds. For heavy water, that is S, Br, I are generally avoided. Because the absorption of sample will be proportional to its molar concentration in the sample cuvette, a corrected absorption value known as molar absorption is used when comparing the spectra of different compounds. Advantages of single and double beam spectrophotometer. Single beam, simple in construction, easy to use and economical. Double beam, it facilitates rapid scanning over wide range lambda region. Fluctuation due to radiation source are minimized. It doesn't require adjustment of transmittance and 0% in and 100% at each wavelength. It gives ratio of intensity of samples and reference beam simultaneously. Disadvantages: single beam, Any fluctuation in intensity of radiation source affect the absorbance. The continuous spectrum is not obtained. Double beam. The construction is complicated. Instrument is expensive. Comparison of single beam instrument and double beam instrument. First of all, single beam. Calibration should be done with blank every time before measuring the absorbance or transmission of sample. Calibration is done only in beginning. The radiation energy intensity changes with fluctuation of voltage. On the other hand, it permits a large degree of inherent compensation of fluctuation in the intensity of radiant energy. It measures the total amount of transmitted light reaching the detector. On the other hand, it measures the percentage of light absorbed by the sample. In single beam, it is not possible to compare blank and sample together. On the other hand, in double beam, it is possible to do direct one-step comparison of sample in one path with standard in the other path. In single beam, radiant energy wavelength has to be adjusted every time. In this, scanning can be done over a wide wavelength region. Working on a single beam is tedious and time consuming. On the other hand, working on double beam is fast and non-tedious. These are references: instrumental analysis, instrumental method of chemical analysis, elementary organic analysis, principle and chemical application, a textbook of pharmaceutical analysis, and analytical chemistry. Thank you very much, all of you.